Every day, the rising sun places the radiation necessary to generate power in our hands. The Plataforma Solar de Almeria in Andalusia, southern Europe, is developing and inspiring research to bring its benefits closer for use by industry, markets and people, spreading the solar thermal technology around the world and making it more and more competitive with traditional sources of energy. What is concentrated solar thermal energy? It is the energy that comes from solar radiation incident on a highly reflective surface, where it is redirected and concentrate on a smaller receiver area, thereby increasing its energy intensity and producing useful high-temperature heat. It can then be used for power production, water treatment and desalination and many other industrial processes, and even stored for later use. But how is electricity generated from this energy? Basically by heating a fluid to produce steam, which is expanded in a turbine and then moves a generator, which in turn produces electricity as it rotates. Come closer and find out more about our facilities. Concentration on a central receiver. At the CESA-1 and the CRS plant, which has a field of completely autonomous heliostats, prototypes, advanced receiver designs and new thermal storage concepts are tested, astrophysics and hydrogen power production experiments are carried out. Linear focusing concentrators. All these facilities use either parabolic trough or Fresnel linear collectors, which concentrate the direct solar radiation on a receiver tube. Some of these are unique, placing the PSA in a privileged position for research and efficiency of these concentrators. Parabolic dish concentrators. These are devices comprised of mirrors in the shape of spherical parabolas which concentrate the solar radiation directly onto a receiver located in the focus for materials testing and experimentation with Stirling motors. Solar furnaces. They are comprised of a heliostat which reflects the sunlight on a parabolic dish that concentrates it on the focus, where there is a test table operable on 3 axes. Thermochemical experiments are carried out with the highest solar concentrations and the highest energy levels. Solar desalination. There is a solar multi-effect desalination plant and another for combining a solar thermal power plant with desalination to produce electricity and fresh water simultaneously. Another test bench has prototypes for studying membrane distillation. Solar water treatment. Research is underway in solar photochemical and photocatalytic processes for water treatment. There are also modern chemical and microbiology laboratories. Measurement of solar radiation, METAS. In these facilities, recently enlarged under a collaboration agreement with the DLR, sophisticated high-precision equipment analyzes all the characteristics of solar radiation and optimizes its application in all the processes at the PSA. Building. The purpose of the AFRISOL building is to demonstrate that it is possible to save 90% of the energy usually consumed in buildings by adapting their design to the climate and environment. It also has a building components test laboratory. The PSA has evolved to improve these renewable energy technologies over more than 30 years, working with reference public entities and private business. One formidable example is the German Research Institute DLR, which has been present at the PSA since the beginning. Our entire team is involved in research in these technologies to contribute to establishing a clean and sustainable worldwide energy supply paradigm, favouring the conservation of resources and environmental protection.